Capacitance of a cylindrical capacitor. Now we derive the capacitance of a cylindrical capacitor. Capacitance of a cylindrical capacitor. Of a cylindrical capacitor. Okay. Suppose there is a cylindrical capacitor with the inner cylinder of radius R1 and is surrounded by a hollow cylinder with radius R2. So now the charge given to the inner cylinder is Q and the outer cylinder is grounded, and due to induction the inner surface of outer cylinder will get negative charge due to induction. They will have same length. They will have same length. And this will be the axis. So this is the axis, common axis. So they are coaxial cylinder. So if you consider one point P at a distance r from this axis, then what is the electric field intensity at that point? So electric field intensity at that point will be, first we calculate electric field. The electric field between the cylinders, between the cylinders is E is equal to lambda by 2 pi epsilon naught r. Now we have to find the potential difference between R1 and R2. We have to find the potential difference between these two cylinders. So in finding the potential difference between these two cylinders, lower limit will be R2, upper limit will be R1. So we go from R2 to R1. So small potential difference is minus EDR. Now to get the total potential difference, we have to integrate. So integral dV is equal to minus integral E into dr. So now dV integral dV is equal to minus integral E into dr. So we substitute that. So integral dV V initial to V final. So initial will be, let's see, integral dV is the total potential difference between the two cylinders. So is equal to minus, what is E here, lambda by 2 pi epsilon naught R into dr. So R2 to R1 we have to take. So now the total potential difference between the two cylinders, we say it as potential of the capacitor. And here minus lambda by 2 pi epsilon naught is constant, integral dr by r. To avoid this negative sign, I interchange the limits r2 to r1. What is integral dr by r? So it is integral dr by r is ln r. So log to the base e, lambda by 2 pi epsilon naught ln r. So if you substitute the limits, you'll get r2 by r1. Lambda by 2 pi epsilon naught ln r2 by r1. Now, lambda, in place of lambda, we substitute q by l. So q by 2 pi epsilon naught l ln r2 by r1. Now c is equal to q by v. So remember this. Now c is equal to q by v. C is equal to q by v is equal to q by 2 pi epsilon naught l ln r2 by r1. So what will be cancelled here? Q will be cancelled. Now you'll get The capacitance of cylindrical capacitor as 2 pi epsilon naught L divided by ln of R2 by R1. So this is what you get.